Hello, my name is Solar. Welcome to CAD CAM demonstration number 4. Today we're gonna cam this part right here. This part has some smooth radii like this, which I will need to do some 3D finishing to be able to finish this surface right here. I've skipped this part is already CADed, so I will just quickly cam it. I will not be doing any fixturing. If I was fixturing this, I would probably have some sort of fixture to hold this round here to be able to finish the other side. But for this, I'm just going to do it real nice and simple. So to get started, I'm in the manufacturer workspace right here to do my camming. So I'm going to do a setup like so. Machine, pause. I'm going to do orientation Z and X. I don't have any lines easily clickable going straight up here, so I'm just going to go to my origin, and then I think Y. So Y, so Z is up. Then X, I will just press one of these. So that goes sideways. This is okay. If Z was going downwards, I would just flip C. I will have a stockbox origin, so I will just pick top left here. I'm just gonna add 2 millimeters to the side, maybe. In this case, maybe I would even go with a relative size cylinder instead. I would probably add a little bit more, maybe 2.5 to the side. I would add 1 millimeter to the top, and then maybe 5 at least on the bottom, like so. This makes it a little harder to grasp on using cylindrical stock like this, but that's fine. I'm going to call this 1010, and then this is operation 1, ESML1-001, I believe. No, I'm sorry, ESML2 001, like so. I'm going to save this as user default. Press OK. Like so. I'm going to rename this to op1, operation 1. Like so. I'm going to start by facing. This is aluminum. So tool, select. Haas N11 shell mills number 1. I'm going to do multiple depths, 1 millimeter maximum step down, finishing step 0.5, like so. Press OK. That looks good. I'm going to do a 3D adaptive. Select tool, N mills, 2 flute 10 mil. Yeah, should be the right one. On heights, I'm going to do model bottom negative 0.1. I'm going to ensure 10% optimal load. This should be pretty okay. I'm going to do 0.1, I think, in axial and radial. I'm going to turn on smoothing. I'm going to I might try machine shallow areas. That's going to ensure that it's going to go all the way here. Otherwise, it might leave a little bit. Press OK. Then I'm going to do duplicate, and then edit. Then I'm going to change the tool. So select. And then I'm going to do the 6 mil instead. So N mills, 6 mil 2 flute. This one should be good. Press OK. And so that's going to, in 2 steps, remove most of the material. This is going to remove probably this as well. Some of this for the camphor, that's okay. If I wanted to save time, I would certainly remove that because we're gonna remove that with a 45. So it's really unnecessary for it to spend a lot of time removing this as well, because we remove it later, but doesn't matter for this. There's a lot of optimizing, I think, that could be done, certainly. For starters, with this one, I would turn on both ways. On both, I think I will do. Both ways. I'm also going to go to linking and then maximum stay down distance. I'm just going to make this a really big number. And this is because over a certain length, it will choose to do a retract and then come back in. But that can add a lot of time. So you're going to see still it needs a lot of them, but it really reduces these yellow bows here. And in some cases, having both ways and a really long maximum stay down distance can really, really help on reducing the time it takes to machine something. Both ways is not as effective. It's best to go climb milling. So, but in materials like aluminum and wood, it's okay. So I will certainly take the time advantage in this case. It certainly leads to more tool wear. So if you're doing a lot of parts, your tools will break a lot quicker for sure. It did this hole as well. I think I would want it to not do that actually. So in this, I'm gonna do height selection. This perhaps. I might even do a machine boundary instead. So maybe what I would do is I would do a selection. So I would do in between this and this. So now it will only do inside here. I would do probably center on. That means that it can go center on line, but not more. I'm gonna put this back to model bottom. So see how that does. And so again, I would rather do a board here, and I would just save so much on time, save so much on headache. So you can see this is just way, way simpler and doing what I really wanted it to do, you know. So I think it can be really good to be selective, a little more selective like this. That leaves a little bit here, but that's okay. I'm gonna remove most of that anyway. So next I will probably do a bore. So 2D bore. I'm gonna check. That's a 10.5 millimeter hole. I would probably still do maybe I would do an 8 mil. So 2D bore, select tool, and mills. This one. Geometry, this. I will certainly make sure that it starts a little higher up, otherwise it might crash. So let's do selection. This should be pretty safe. To model bottom and a little bit more, so negative 0.1. That's okay. Like so. Okay, that's looking pretty good. I think I'm ready to start finishing these 3D surfaces. So there's lots of approaches. I would probably do a parallel in this case. You could also do a scallop, but a parallel would probably be a pretty good option. Select tool. So N11 copy mills. That's where we have all the ball mills. I'm gonna try just as is, probably. I might do a selection. So select this and try that and see what that does. That's okay. That looks pretty good. I might, it really depends on the function of this, which ways I want the lines. In this case, I might want them 90 degrees to this, and that's because there's going to be a swivel on this. And so if they're going this way, even if they're really smooth and really nice, that's going to create this sort of mechanical obstruction, you know. So if I go to edit, and then in passes, I'm going to do 90 degrees in the pass direction. And then step over, I'm going to do 0.1. And so that's going to really increase the amount of lines a lot. You can see these simple ones are pretty effective actually in calculation times. With these more complicated ones like I think like blend and flow perhaps and stuff. There's some more like complicated ones. These ones pretty effective, honestly. This looks really good, I think. That's a good start. Then I might wanna finish the sides and do the chamfer. So to the contour. Select tool. End mills. I might do 14mm 3 flute. Geometry. This. Go a little bit deeper, negative 0.1. Like so. Then to the contour again. Select tool. Chamfer tools. 45. Geometry. This. So in this case, I don't want it to do it this way. I will select the line again. I will do open chain. Select that one. Press OK. And do the same here. Like so. I'm going to do some tangential fragment extension distance, so that adds just a little bit more distance, so that takes everything. So maybe 5 or something. I'm gonna add some chamfer tip offset. So let's try 1.5 maybe. That's okay. That looks good, I think. Seems to have taken everything. So you can see what I mean with the tangential fragment distance. If I didn't have that, it would start right here. And so it might have left a little bit of material right on the edge here. So that's what that does. You just have to make sure that it doesn't like crash into something else, you know, or mill into something else. Yes, that looks pretty good. Lastly, I would do the chamfer there. In this case, this is a not two-dimensional chamfer, you can see. So this 2D contour will not work for because that's only 2D, you know. So I might try trace for this. This one you can use. This one works in 3D, even though it's a 2D operation. I think this one can do, let's see, a left. This one also has this chamfer option. So let's try 1.5. Let's try that. Yeah, that looks pretty good. Might be a little bit too deep, but that should be pretty good, I think. Before I machined, I would simulate and see how deep the tool actually went, so that it's not going too deep. But it should be pretty good. Okay, next I would machine the second side. So setup, C machine, ZX. Like so, flip C. I'm gonna do a model box point. I'm gonna do center like this. Top probably. This is 10, 20. Up 2. That's okay. I'm gonna turn on continuous machining so that I can keep the stock from the last operation. I'm gonna duplicate these two or copy paste like that. Rename this top 2 like so. I'm gonna finish this surface and I'm gonna chamfer, so flat. Just the same tool to the contour, select tool. Okay, so I will press up 2 here. I will press Control G to regenerate. So, all right, looks pretty good. I think with the flat finishes as well. If I wanted that really, really perfect, maybe I would do a bore as well. Leave some stock to leave against the surface here, do a bore. And that way there's no, always when you do like to the contour or whatever around us, like a surface like this, there's always going to be a mark where the tool enters. So let's say the to the contour here, it's going to leave a mark right here. You can't avoid that. In this case, this is a machine surface that's going to go in a T-slot, so I would want that to be pretty precise. So that's probably what I would do. To see if I missed anything, I will simulate this. So simulate. Like so. I'm going to go to the end. And then with a comparison mode on, I can see if I missed anything. So green is finished, blue is material left, and red is too much. Looks pretty good. You can see where it took maybe a little bit too much when it did the chamfer in here. So maybe I would adjust that a little bit. Ultimately, you know, chamfers are mostly cosmetic. So unless this was a machine surface, like something that really needed to be really precise, it's not. So it unless it maybe went a little bit too deep, so there's like a little fat spot there, should be fine. You know, it's not always possible to completely match. I might increase the or rather decrease the step over of the parallel finishing here if I wanted it to be even more smooth. 0.1 is already pretty smooth, but you can go even further, of course. And yeah, that's pretty good. That's about it. This has been CAD/CAM demonstration number 4. Thank you for watching.